Next up, properties of logarithms. So I've got our two triangles of power here with a b base and then an x in different spots to teach you about what we call the inverse properties of logarithms. So the first triangle has b in the base and x up in the exponent. So this is going to be b to the x in the bottom right. All right, but remember what the top was. The top was that exponent, that logarithm, so that x is equal to the log base, whatever's on the left bottom corner, b, and the argument was whatever is on the right bottom corner, b to the x. All right, and this gives us our first property. This says that the log base b of b to the x is equal to x. What does that mean? This is telling you that if you have an exponential function plugged into a logarithm and their bases match, that the log base b and the b to the x will cancel out and the x will just fall down on the ground. It's kind of like taking the square root of a square or vice versa. They're inverse functions, they cancel each other out. So let's look at the other one with b on the bottom left and x on the bottom right. We know that up top is the exponent, which is the logarithm. So we would say that up here, this is the log base b of x. Now, if I write that triangle with exponential notation, this would tell me that b to the log base b of x is equal to x, right? And again, this is where I have one of these functions inside the other. I've got a teeny tiny little logarithm up in the exponent of the b. So I have b to the log base b, they're canceling each other out, and the x is just falling down on the ground. Okay, so these are our two inverse properties. Basically, when we compose a logarithm with its partner exponential in either direction, we get x. All right, so let's put these two new properties to good use. I have a logarithm here that we're asked to simplify log base p of p to the fifth. P is, I don't even know what number, but it's the base of the logarithm and the base of the exponential. So our new logarithm rule down here that says if the base of the log matches the base of the exponential, then the log and the exponential will cancel out, and whatever the exponent is going to fall down onto the ground and be our answer. Okay, so make sure you don't write that as a exponent 5. It's big on the ground in a regular font size. All right, how about log of 10 to the z? So let's remember that log without a base written is a log base 10. Log base 10 of 10 to the z. And again, the base of the logarithm and the base of the exponential match. So our property down here, our inverse property, says that the log base 10 and the 10 to the will cancel out, and the z will just fall down on the ground. All right, let's try another one. How about e to the natural log of x? All right, so natural log, remember, is the log base e. So you could rewrite this one as e to the log base e of x. This one's going to make use of our other inverse property, b to the log base b. So that log base e is tiny up in the exponent of the e. And our property says that these cancel out, and then the x falls down on the ground. And that's all it is. All right, so these are our first properties of logarithms. We have a few more that we still need to learn.